use a line and a linear function to model a linear relationship between data in a scatter plot. Think about this question during the lesson. Michaela is a speed skater and hopes to compete in future Olympic Games. She researched the winning times for the past 50 years. If the trend in faster speeds continues at the same rate, what equation can she use to predict future winning times? What relationship might there be between the two measurements? Step 1. Draw a trend line for the data. The trend line has a negative slope. The winning time tends to decrease from year to year. Step 2. Write an equation in slope-intercept form to represent the trend line. In order to write an equation for the trend line, we need to know the slope of the line and the y-intercept point. The y-intercept is about 2 4/10. A calculator can help us find the slope. Rise over run is equal to -2/10 divided by 15. The equation of the trend line is y is equal to -133/10,000 times x plus 2 4/10.
Write an equation in slope-intercept form to represent a trend line that could be used to predict average fuel consumption in miles per gallon in 2025.
The equation of the trend line is y equals blank x plus b. So this is a formula for slope. It's y equals mx plus b. So that's what the blank spaces are for, the m and the b. The b represents your y-intercept, and the m represents your slope. So we need, and that's the equation they're looking for. So first, to find the y-intercept, we look here on the point that is on the line. So in my opinion, if we look from this line to this line, is 12 to 18. So that's about 6 miles per gallon in between these two numbers. So this line here that doesn't have the number is halfway between that. So to me, half of 6 is 3. So this number on the number line here would have to be 5, which would be, not 5, but 15. So I'm just going to write 15 right there. So the y-intercept, I'm just going to choose a different color. My y-intercept is 5. I keep saying 5, 15. So now to find what our m is, which is the slope, we have to use another formula or another equation. And that equation is this. I'm going to write it. I'm going to write it over here. So y2 minus y1 over x2 minus x1. So this equation is how you find your slope when you're given a graph like this and you're given points on a line. So you know on a graph you have your coordinates with an x and a y value. So to find the slope, you pick 2 points on the line and you use them to find your slope. So I'm going to choose 2 points on this trend line. So I see here at 10, so my x would be, my first x, I didn't mean to write x. My first x would be 10. And if I go up to 10, and my y would be 18. Okay, that's my first x, my first y. Now if I look further along the trend line, let's say I go up a little bit more and I come here. that is going to be 25 as my second x, and my second y would be about halfway between, that'll be another 6, so that'll be 21 here. 21, so that would be maybe about 22. 21, 22, 23, 20, 24, maybe about 22, 23. It could even be about 22.5. Just so I don't have a decimal, I'm just going to go with 22. Just so I don't have that. So now I have my first set of coordinates and my second set of coordinates. Now I have to put them into the equation. So now my second y, this is my second y, goes here, minus my first y, which is 18. Now I get my second x, which is 25, minus my first x, which is 10. And then you subtract. So 22 minus 18, 25 minus 10. Once I subtract, I get 4 over 15. So now my slope is 4 over 15 because that fraction cannot be simplified. And technically, instead of a regular equal sign, it should be the squiggly equal sign, which means approximately, because that slope is not exact, because that's going to be a decimal with a whole lot of numbers, and depending on how you view the graph and what number you use, because if I use 22.5, that number would be slightly different to represent that slope. So we're going to use the approximately 4 and 15th x plus 15. So the equation would be this.
The owner of a Mexican food truck collected this data on the truck's camoyada sales. Part A. Construct a graph to represent the data and draw a trend line.
All right, so here's a graph to represent that data with a trend line, and we're going to get our y-intercept because that line touches our y-axis. So there's our y-intercept here. Then it says what equation relates the temperature x and the number of camoyotas purchased, which is our y. And the equation, we have to use the that equation I told you about, the y2 minus y1, x2 minus x1, and they got 240 over 40, which simplified to 6. So in this equation, we have y equals 6x plus 80, and the 80 is our y-intercept. That's the number that's on the y-axis, and then we solve for our slope, which is at 6. What does the rate of change or slope represent in this situation? The rate of change or slope describes the change in the number of camoyotas purchased for each 1 degree of temperature increase. The number of camoyotas purchased increases by an average of 6 for each 1 degree increase in temperature. What does the y-intercept of the line represent in this situation? The y-intercept of 80 represents the camoyotas purchased when the temperature is at 0 degrees. So approximately 80 are sold when it is 0 degrees.
A scatter plot shows the relationship between the number of tamales purchased and the outdoor temperature in degrees Fahrenheit. The equation of the trend line is y equals -2 times x plus 350. What do the slope and y-intercept represent in this situation?
The slope, which is -2x, or -2, represents the decrease in the tamales that were purchased by the average of 2 or 2 for each 1 degree increase in the temperature. And the 350, which is our y-intercept, represents approximately 350 tamales were purchased when the temperature was at 0 degrees.